Okay. The last the last video, the last example, it did not take because I did not realize that there is a length on the time of your movies, and the last movie was a bit too long. I was about 3 seconds from being done. So now let's work. I trimmed off, and so now let's work the last example. This is the last example. What we're going to do is we want to find the surface area of this truncated cone. Now, something to notice is that in the last example we found the cone, we found the volume of the cone. Now we're going to look at the truncated cone, and we're going to find the surface area. And so I'm trying to pull up something. So here's the last question we had, where we found the volume of the cone, right? And we found the volume of the big cone minus the volume of the small cone. Now we want to find the surface area of just this piece. Okay, so that's what we're looking at. And we don't even know the dimensions of the big piece. And so we just are going to use what we know here. Now, I need to find the slant height. Surface area means slant height. So the first thing I need to do is find L, the slant height. I know that this is 40 centimeters, and I can find that this piece is 40 centimeters. This is a right triangle. It happens to be a right isosceles triangle. So I can find that L squared equals 40 squared plus 40 squared. Well, L squared equals 2 times 40 squared. So that means that L equals 40 square roots of 2. Right? Take the square root of both sides. The square root of 40 squared is 40. The square root of 2 is the square root of 2. So L is 40 times the square root of 2 centimeters. Now, the surface area is the area of the top plus the area of the bottom plus the area of the lateral face, or the side, or the face, or I've called it different things at different points. So that's the surface area. So now what we're going to do is we're going to find each of these areas individually. Okay? So the area of the top is a circle, so it's pi r squared. And it's a circle with radius 60, so it's going to be pi times 60 centimeters squared. So that's 3,600 pi centimeters squared. The area of the bottom, again, is a circle, so that's pi r squared. So that's pi, the diameter is 100 centimeters squared. So that's going to be 2, 3, 4 pi centimeters squared. So it's going to be 10,000 pi centimeters squared. And so that's the area of the top, the area of the bottom. Now we have to think, what is the area of the side? If I want to unroll, so this is the picture I have, and I want to unroll that picture, and so what is the shape of that side? Okay, that side happens to be a trapezoid. So if I unroll it, I have a trapezoid, right? Okay, it's a trap. Okay, where my slant height is 40 square root of 2 centimeters. The area, this base, is 2 pi r, so that's 2 pi times 60 centimeters, so that's 120 pi centimeters is that base. The bottom base is 2 pi r, but that's 2 pi times 100 centimeters. So that's 200 pi centimeters, right? And now I need to find the area of the side. So that's going to be 1/2 the slant height times B1 plus B2. So that's 1/2 40 square root of 2 centimeters times 120 pi centimeters plus 200 pi centimeters. So the area is going to be 20 square root of 2 centimeters times 320 pi centimeters. And I get that that is 6,400 pi square root of 2 centimeters squared. So my surface area is going to be 3,600 pi centimeters squared plus 10,000 pi centimeters squared plus 6,400 pi square root of 2 centimeters squared. And so what I get as a surface area is 13,600 pi centimeters 13,600 pi plus 6,400 pi square root of 2 centimeters squared. And that is my answer, and that also concludes the lecture for 10-3 and the last lecture for this course. Thank you very much, and please let me know if you have any questions.